Morning, everybody, or everybody who's here. Did Mrs. Ward finish, for those of you who are in here listening to me? And if you want to throw some green checks in, that'd be great. Looks like we're missing a few, but we'll maybe wait a second or two, and I have a feeling a few people will trickle in. Just want to make sure Mrs. Ward's done. Yeah, Devin says she's done. Green checks are coming in. Okay. She did finish. Okay, well, maybe people are just loading it right. Fair enough. People are probably just loading the Blackboard, and it does take a while, right? You know, a couple minutes here. Like always, I would like to start with any questions you might have had. I have a feeling you guys might have some questions about the XY intercepts questions off the learning guide. So if you want to fire those into chat, I'd be happy to do that. If nobody has any questions, if you guys are all experts at that, then we can move on to this function notation stuff, which is pretty straightforward. Nothing terribly difficult about it. All stuff you've done before, but just kind of a different notation, a different look. So the idea behind function notation is we're going to do just basic substitution, which you guys have looked at. Substituting numbers in for variables and just solving equations. So stuff you've spent a lot of time looking at, and we'll have a look at it here as well. It's just kind of a different way of writing things, so nothing terribly difficult. Page 7, number 9, that'd be a great way to start. Daily, page 5. Of course, you wanted the second half of the learning guide. Maybe 8, 7, number 9. Hopefully that's the right one, Daily. So this one's asking us to plot the x and y intercepts. And I think it was the question above. I just wrote a little note up here for number 6. So same sort of process for number 6 as number 9. Cool. So here we go. What we're going to do is take our equation, and we're going to find our, let's go with x first. To find the x-intercept, we're going to let y equal to 0, and then solve for x. So this is kind of something you're just gonna, get used to doing, hopefully. So I'm gonna take my equation, 8x plus 3y plus 24 is equal to 0, and anywhere there's a y, I'm gonna put in 0. So I get 8x plus 3 times 0. And plus 24 is equal to 0. All right, so doing the multiplication in the middle there, I get 3 times 0 is just 0, so I get 8x plus 24 is equal to 0. I'm just going to solve for the x. That's what I'm doing now. So I get, trying to get x by itself, I'm going to subtract 24 from both sides of my equal sign. I get 8x is equal to negative 24. Divide both sides by 8. And I end up with x is 24 divided by 8. How many times is 8 going to 24? So we get negative. All right, so that means my x-intercept is negative 3. So I'm going to plot that on my graph. 1, 2, 3. So negative 3, 0 is that point. Now I need to do the same thing with the y-intercept. Kind of took a little bit of space up here, so maybe I'll fire it off onto the right. My y-intercept is where it crosses the vertical axis. I'm going to let x equal to 0 and then solve for y. Here we go. Start with the same equation. 8x plus 3y plus 24 equals 0. And I'm going to put a 0 in for x. Plus 24 equals 0. Okay, so 8 times 0 is just 0. Then I end up with 3y plus 24 is 0. I subtract 24 from both sides. 3y is equal to negative 24. I divide both sides by 3. I end up with y is negative 8. So now I plot that point, 5, 6, 7, 8, down here. So this is 0, negative 8. Now I have my 2 points. I can connect them with a line. And there's the line that equation represents. Abby, this is on page 7 of the second half of the learning guide. This was question number 9. All right, so for those of you who are just joining us, we just did question number 9 from the learning guide, the second half, asking to plot a line using the intercepts. So when we want to find the x-intercept, we make y equal to 0, solve for y, or solve for x, sorry. When we want to find the other intercept, we make x or y equal to 0, solve for x. And that's how we find the intercepts. Once we figure out where it crosses the vertical axis and where it crosses the horizontal axis, we end up with 2 points. We connect our 2 points with a line, and we're good to go. So perhaps, now that a few more people have joined us, you want to throw in a check mark just so I know that everyone's kind of with me right now, and then maybe we'll just move on to the last lesson of chapter 5 here. Yes, I heard Mrs. Ward was getting you guys to do some writing, which is good. It's all right if you're just tuning in, you haven't missed anything new yet. So just going over some stuff from the learning guide. That's good. A few more people have some green checks in there. So this is lesson 5, and we're going to talk a bit about functions and properties of functions and how we're going to deal with them. And this is the last section of the unit. So we're going to just do this one today. Monday's class, I'll go over a review of anything that you, any questions you would have had from all of chapter 5. And then I'll get you guys to submit your learning guides on Tuesday, which means, if you finished your learning guide over the weekend, that's fine. So you have the weekend to work on the learning guide. Monday's class is a review. Tuesday, Wednesday, if you wanted to write the test either Tuesday or Wednesday, that'd be perfect. We're going to have the math tutorial again on Wednesday. We don't have anything special going on Wednesday. Yesterday we had a half day, so we did some learning as teachers. So that's kind of the next few days, what they're going to look like. After that, we have Unit 6 and 7, which will get done before the break in the next 3 weeks. And then you guys have the winter break, Unit 8, and then we're done the course. So we have 6, 7, and 8 left, 3 units. We're doing good. We're looking good in terms of our time. So let's look at lesson 5, and then if you guys have any questions at the end, I'd be happy to go through them if I have time. So we're talking about functions and function notation. Remember, the definition of a function is if I give you an input value, you're going to give me one unique output. And a relation was something like I give you one input, let's say I say, here's a 1, and you say, okay, here's a 2, and then I say, okay, how about if I give you a 1 again, what are you going to give me? And you gave me a 7. That's a relation. I give you one input, you give me two different outputs. We're talking about functions. For each input, you get one unique output. So if I give you a 1, you're always going to give me a 7. So if that makes a little bit of sense, let's look at this. There's this idea of a function machine, and when I first started talking about functions, I was talking about a black box where you just had an input and it give you some output. This function machine, or this black box, this is how one's actually telling us what the function is. So it's saying, okay, you can give me an input, any number you want. It goes in, I'm going to multiply it by 2, and then add 3 to it, and then you're going to get an output. It's going to be some unique number. That makes a little bit of sense. So the rule of this function machine, in this case, it's asking us to multiply by 2, then add 3. So sometimes we'll give you what the function machine is, and other times you'll just get an example. And it'll say, you know, the input's 1, the output's 5. The input's 2, the output's 7. And you need to kind of think about, you know, okay, what's going on with that number? If I have just maybe a table of values, I need to figure out the function from just a table of values. So we can get you to work backwards sometimes. Sometimes we'll tell you what the function is, you move forwards. So looking at the table of values here, imagine we didn't know that it was multiplied by 2 and added by 3. Could you figure that out by just looking at the table? So if I give you an input of 1, you give me an output of 5. So the first thing I think is, maybe I'm adding 4 to get from one step to the other. So I go to the next one and I try it and I say, okay, 2 plus 4 is 6. Oh, that doesn't work. All right. So what else could be happening? So you keep on kind of thinking about what's going on here until something kind of makes sense. In this case, it's multiply by 2 and then add 3. So let's fill out the rest of the numbers. 1, 2, if I put in a 3, I'm going to go 3 times 2, and then I'm going to add an additional 3 to it. So 3 times 2 is 6, plus 3 is 9. Does that work? Yep, that works. All right, now I'm going to give you an input of 4. So 4 is my input, then I'm going to multiply it by 2, and then add 3. So 4 times 2 is 8, plus 3 is going to give me 11. Now you can see there's a bit of a pattern evolving here, but if I gave you 13, could you work backwards? So could you say, I've been given 13. I know I have to add 3 to something, multiply something by 2. What is that something? So what times 2 plus 3 gives me 13? So that something in this case is going to be a 5, just because we're continuing to move on. But does that work? 5 times 2 is 10, plus 3 equals 13. Does 13 equal 13? Yep. Okay, so we know we're doing okay there. So just looking at the patterns, that's fine. I mean, you're going up by 1 each time on your input. Just continue to go up by 1. The output might get a little bit tricky sometimes if you don't know what the function is. But yeah, these are all perfectly valid ways to kind of go about these types of questions. So we finished the table of values. We filled it out. So the next thing, let x be the input value and y be the output value. Create an equation for this function in terms of x and y. So what we're saying is, if everything here in my input column is x, and everything here in my output column is y, can you come up with an equation that figures out all of the values? So if I put an input of like 3,000 in, would the output work? Or if I put an input of minus 22 in, what's the output going to be? So I need an equation that's going to work for all values of this function. So this function is going to just work all the time. So an equation, what we're doing is we're taking something and we're multiplying it by 2. And then we're going to add 3 to it. And that something is going to be our input. So that's going to be our x. I guess x times is a little bit confusing. So x2, and then the output is what I'm going to end up with. So I'm going to just rewrite this to let it make a little bit more sense. So our output is going to be 2 times the input plus 3. So 2x plus 3. We usually write the number in front of the variable, so that's why I switched the order from x times 2 plus 3. But it's the same thing, right? The order of multiplication doesn't matter. So that's an equation that'll figure out any output for any given input. If I say the input is 7, you'd go, okay, 2 times 7 is 14 plus 3 is 17. The output's going to be 17. So that's kind of a bit of an abstract example. Let's look at something a little bit more concrete that you guys can kind of relate to. The next function machine here is going to tell us, if I say you have a bunch of quarters, how much money do you actually have? You know, if I had like 4 quarters, I have $1. Something that would just figure it out for any number of quarters, how much money are you going to end up with? So they've kind of set it up for us here. When the input is Q for quarters, the output is V. Think about it as like V as in maybe value. So the value of money you have, if you want to think of it that way. So if I'm going to take the number of quarters I have, how am I going to figure out how much money I have? What am I going to do to the number of quarters to figure out the money? Well, each quarter is worth 25 cents, so it makes sense to multiply this by 0.25. So if I took the number of quarters, Q, and multiplied it by 0.25, that would tell me how much money I have. So if we want to come up with an equation that's going to work for any number of quarters, I'm going to take V, the value of the money I have, and that's going to be equal to 0.25 times Q. So that equation works for any number of quarters. If I had 5 quarters, 5 times 0.25 is 1.25, so I have $1.25. If I had 5 quarters, $1.25, that makes sense. Now, this is kind of where this unit comes in to play, like everything up to here kind of makes sense. The only thing is we're just going to change how we write this value. So V is a function of Q, meaning the value of the quarters we have depends on how many quarters. This is kind of getting back to the independent dependent variable. So V of Q is equal to 0.25 times Q. And in this notation, V, or the value, is dependent on how many quarters you have. Sorry, V is the dependent variable, and that V depends on Q. So kind of talking about the notation again, if you had something like V of 3, remember we said this is, if I were to say it, it would be V of 3. And if you want to think of it this way, what is the value of 3 quarters? V of 3. The 3 has replaced the Q. So represents the value of the function when, what did we replace the Q with? We replaced it in this case with a 3. So what do you got here? And you can times the value by 4 to figure out how many quarters you have. Does that work? If I had like a value of 1.25 times 4, does that equal 5? Maybe, maybe not. Does it work for all values? Let's find out. All right, so we decided the equation we wanted to write looks like V of Q, or the value of the number of quarters I have, is equal to 0.25, because that's how much money each quarter is, times the number of quarters. And in this example, I'm asking you to find V of 3, so the value of 3 quarters. If you want to think of it this way, this 3, this is replacing Q. So if I have 0.25 times Q, I'm not interested in the equation now. I'm actually interested in putting in 3 right into this equation. So the 3, everywhere there's a Q in the equation, the 3 replaces it. So the value of 3 quarters is equal to 0.25 times 3, or 0.75. We should probably just maybe write it like a general statement here. So the value of V is $0.75 when Q is equal to 3. Or if we have 3 quarters. Now Alex has put in a bit of a statement here. So if you have $50, you have 200 quarters. If you have $1,235.75, you have 4,943 quarters. Seems to work for everything, so we're just multiplying by 4. And maybe you don't have to write this down. I'll just do it in red over in a little box here on the side. But if you want to think of it this way, the example you used for $50, Alex, so you have a value of $50. That's equal to 0.25 times the number of quarters. So if I want to figure out how many quarters $50 is, you're telling me I'm going to multiply by 4 to figure it out. It turns out that dividing by 0.25 is the same thing as multiplying by 4. So that actually works out nicely. So we end up with 200 is equal to Q. So yeah, we're actually going to end up doing that in the next couple of examples here, Alex. You're just, again, a bit ahead of me, so you don't need to write this down, but that's kind of what you're saying. And there you go. So again, the math here is something you've done before. You've taken a general equation, and I've said, okay, x is 3. Plug in 3 and then just solve. See what the equation equals. You've done this before. The only thing new is just how we're writing it. So some people get really kind of caught up in what it looks like. Don't get scared by this function notation. It's just a new way of writing something you already know how to do. The math hasn't changed. It's just how we're writing it. Let's look at a couple more examples. All right, so V equals negative 0.8 times D plus 50. It's telling me V is volume in liters, and then D is distance in kilometers, the gas tank. So basically, we're figuring out how much gas is left in our tank after we've driven some distance. So the dependent variable is the volume of gas. It depends on how far you've driven. So D is the independent variable, the distance you've driven. V, the volume of gas, is dependent on it. So we're going to describe the function and then write the function with function notation. So as a general statement, the volume of gas remaining in a tank I guess, in a vehicle's tank. Not to be confused with a real tank, is a function of distance traveled. So, how far have you gone? Okay, a little less gas you're going to have. Kind of makes sense. So we're saying that volume is a function of distance. So I'm going to take the equation that I had up above here. This V is negative 0.08 times d plus 50, and I'm going to rewrite it. So negative 0.08 times the distance plus 50. And in order to put this in function notation, which is, the math is the same, like I've been saying, we're just going to take V, the volume of gas, is a function of the distance. So V of D. V is a function of distance. The volume of the tank is a function of how far you've driven. So I've just taken a regular old math equation and I've just changed how it looks on one side. Why do we do function notation? That's a great question. I guess the title of the course we're in is Foundations of Math and Pre-Calculus. And when we move into calculus, function notation becomes really important once you start doing derivatives and integrals and things like that. And very well, probably 3/4 of you will never move on to calculus. But if you do any math beyond grade 12, it's calculus. That's when calculus starts. So we're kind of building the foundation for you to be able to do calculus. Whether you're going there or not, that's just what our whole system of mathematics, all the way from K to 12, is based on teaching you calculus. Whether that's the right thing to be teaching you or not, it's kind of neither here nor there. But there's some people that are saying, not everyone should know how to do calculus. Not very many people need to know how to do it. So maybe we should be teaching in K to 12 stuff like statistics and probability and put more emphasis on that sort of area of math instead of building you up to do calculus. So that's just kind of where we're at. A little bit of an aside. So the next part of the question says, determine the volume of gas, V of 600. So this means determine the volume of gas in the tank after you've driven 600 kilometers. V of 600, volume of gas after you've driven 600. So let's start with our equation. V of D is equal to negative 0.08 times the distance plus 50. Now I'm asking you to find the volume of gas in your tank when you've driven 600 kilometers. All right, so what did I do? Well, I said, okay, I'm going to take that D and I'm going to replace it with 600. So if I do that on the left side of my equation, I should also, so I can stick with red here, I should also do it on the right side of my equation. So anywhere I see a D over here, instead of writing it as D, I'm going to write it as 600. Is value just mean volume? So I guess it's a poor choice of letters on my behalf because we just use V to represent value, but now we're using V to represent volume. It's just the V isn't what's important. It did mean volume, now it's, or value, now it's volume. It's just a bad choice on my behalf, I suppose. You could make it some other thing. Instead of volume, you could write it as like T, how much gas is in the tank. You'd have like T of D, but then T kind of sounds like time or temperature. So maybe that's not the best letter. So I don't know. I just can't win today. We used V again. Sorry. All right, so negative 0.08 times 600. So I'm just going to leave this left side as V of 600. Negative 0.08 times 600 gives me negative 48. Then I'm going to add to it 50. So I'm just bed massing it. The best letter is O, Alex. Well, O kind of looks like 0. And then now I'm getting confused with zeros and O's and just can't win. I'm telling you, there's no winning. So we have volume of gas in our tank when we've traveled 600 kilometers is equal to 2. And that is the answer. Now, going through it, I was kind of clearly explaining it, at least I believe I was clearly explaining it. So we should probably write some sort of sentence here to kind of demonstrate that we know what's going on. We know what this value represents. So if we had something like, when the car has traveled 600 kilometers, the volume of gas remaining is 2 liters. So if we've driven 600 kilometers, we have 2 liters of gas left in our tank. Some good points here, Alex. O doesn't look like 0 if you don't write it messy. You've done math with me for 3 months now. You know that there's no saving my messy writing. So if I write an O and a 0, they look the same. And I think you were the one that questioned my T's when I first drew them with a little foot on the bottom. Now you're drawing lines through O's to represent something different. We've come full circle, Alex. Okay, so this is kind of getting back to the question that you actually asked, Alex, on the previous page. If I multiply it by 4, it gives me the number of quarters. We're working backwards. This question is saying, determine the value of D. So I want to know what the distance is when V of D is equal to 26. And what does that represent? So let's start with the equation again. V of D. So the volume of gas in my tank, it's a function of the distance I've driven, is negative 0.08 times the distance plus 50. Now the question says V of D equals 26. What is D? V equals volume, V equals value. V could be vehicle, number of vehicles sold, depends on the day of the week. V could be whatever we want. Anything that kind of begins with V we could use. I know it's confusing. And you could do that, Alex, write it out as volume as a function of distance or value as a function of distance. Just in terms of the mathematicians, I said they were lazy, and then I went kind of back on that and said, well, we're efficient. Writing the word volume down or value is that's a lot of letters that we probably don't need to write down. And within the context of the question, if somebody were to look at the question, you see that V is defined as volume. We've gone out of our way to kind of describe it, so there you go. All right, so what does this mean? V of D equals 26. Well, the V is the volume of gas. So what this question is really saying is, the volume of gas left in your tank is 26 liters. How far have you driven? So instead of saying, okay, we drove 600 kilometers and we have 2 liters left, kind of going backwards. We're saying, okay, you have 26 liters left. How far have you driven? So we're going to kind of go backwards. Just like before when we were looking at the quarters, we said, okay, you have 3 quarters. How much money do you have? The value of 3 quarters was 75 cents. If I said, hey, you have 75 cents, how many quarters do you have? You're working backwards. Divide by 0.75, you end up with 3. So what we're going to do is, we've said that the V of D is equal to 26. So in my equation, I'm going to replace V of D with 26, because I know that it's equal to 26 in this example. So I have 26 is equal to negative 0.08 times the distance plus 50. Now, again, we're trying to figure out how far we've driven if we have 26 liters in our tank. You'll notice in the question, the only variable I have is D. And this is going to happen a lot, just in terms of math in general. If you have an equation with only one variable in it, you can solve for that variable. You can do basic algebra, bed mass, backwards sort of stuff to move everything around until you just figure out what that thing is. So that's what we're going to do here. So what I'm going to do is, I'm going to subtract 50. Well, I guess I could do a couple things. I'm trying to get the D by itself. So I'm going to move the 50 to the other side, and we'll go from there. So what I'm going to do is I'm going to subtract 50 from the right side, and I'm going to subtract 50 from the left side. I'll put a little note here. Solve for D, which is distance. All right, 26 minus 50 gives me negative 24 is equal to negative 0.08 times D. And then I'm going to divide both sides by negative 0.08. If I do it to the right, I have to do it to the left. I'm dividing a negative by a negative on the left. So negative 24 divided by negative 0.008. That's going to give me positive 300 is equal to D. What have I just done? What does this mean? I said you started with 26, so the volume of gas was 26, and then we did some calculation, we moved a bunch of stuff around, we ended up with D is equal to 300. So it's important to kind of maybe take a step back and just think about what that D meant. In the very beginning of the question, we defined D as the distance. So I know this D is 300, and the distance was measured in kilometers. So it means the distance driven is 300 kilometers. So if you think about what we did is, in the first part of the question, I said, you've driven 600 kilometers, how much gas do you have left? And we figured out it was 2 liters. Now we're doing the opposite. You have 26 liters in your tank. How far have you driven to get that 26 in the tank? So 300 kilometers. That means we have 26 liters left. So we should come up with a statement. V of 300 is equal to 26. What does that mean? So this means when we've traveled 300 kilometers, we have 26 liters in the tank. All right, so the idea here is that the math that we're doing is stuff you've done since grade 9 at the very least. Maybe some of you saw it a little bit earlier in grade 8. The only thing that's changing is just how we're writing it. We have this, what we call function notation. So the math you've seen before. It's just how we're writing it has changed. The only thing that kind of ratchets this up a little bit is we could ask you on a graph. So I believe that the learning guide actually has a couple graphing questions, or maybe the only question is a graphing question. Down here, no, here we go. So maybe let's just look at this as a group. So this is off of the learning guide. Taylor, you don't remember this. How about if I had written something like y is 0.25 times 3 plus 2. What does y equal? Or if I'd written something like 23 is equal to 0.25 times x plus 2. What does x equal? Those are equations that you've solved before. Substituting a number in for a variable, solving for the other variable. This is stuff that you have done. It's just written with new notation. So there's nothing different about it other than just how it kind of looks. That's the only additional thing we're doing. So f of 6 is equal to what? What does this mean? Well, if we look at number 13 up here at the top, it says y is equal to f of x. So y is f of x. So what this means is, what does y equal when x is 6? So in this case, the x has been replaced with a 6. So I'm going to go to my graph and I'm going to say, okay, x is 6. I'm going to find x is equal to 6. This is my x-axis here. Here's 6. If my x value is 6, what does my y value equal? So that's that point there. Remember, this equation is this line here. The equation is the line represents the equation. So I'm saying, okay, f of 6, x is 6, what does y equal? In this case, I'm going to read off this point as 1, 2, 3. So I would write this as f of 6 is equal to 3. Or, when x is 6, y is equal to 3. I have an ordered pair. 6, 3. Letter B here, same sort of process, except we're kind of working backwards. At the very top, I said, okay, f of x is equal to y. And in this case, f of x is equal to negative 7. And I'm asking you, what does x equal when y is equal to negative 7? So this is from up here. So go to the graph. I'm saying y is negative 7. So let's find y is negative 7. There's negative 5, 6, 7. So this is my y value. What does x equal when y is negative 7? So I'm looking at this point because that's the equation that I'm dealing with. When y is negative 7, what does the x value equal? If I take this back down to my, or up I guess, to my x-axis, that's negative 6. So I can say x is equal to negative 6. Or I could write this as an ordered pair, negative 6, 7. Or I could write it as f of negative 6 is equal to negative 7. In this case, this is my x, this is my y, which is my ordered pair. So all just different ways of writing the same thing. The actual calculations using the equations is pretty straightforward. When you start dealing with graphs, it can get a little bit trickier, but don't get caught up with the notation. When you have something like g of x is equal to something, think of this as y. And then you have maybe like 2x plus 3, there's your x. So if I had written an equation y equals 2x plus 3, you could say, okay, you know, maybe y is equal to 3, or I could say x is equal to something. It's just kind of a different way of writing these things. So, like I said, and Abby's she's caught up with me. It's just how you're kind of framing everything. You're using different letters, f of x, g of x, whatever, which is just like the y, and then you have some equation. You can substitute values in, you can go from there. It's going to take some practice, and unfortunately the learning guide only has this one question involving graphs. But in the course, you can always go into the function notation lesson. I have to activate my Java. Get rid of you. And I can go into the practice assignment, and it just has a bunch of questions with function notation. So, you know, I can go through these and saying f of x is 2, I can substitute the 2 in for x over here on this side, and I can solve. Same sort of thing there. So maybe go through a few of these, see how it works out. And again, there's no more graphing questions, which is unfortunate. But that's just how she goes. You'll probably end up seeing more of these equation type questions than you will the graphing ones. That's function notation in a nutshell. Now, a few of you kind of trickled in late. Not late, but you just kind of showed up when you did. I just want to make sure nobody had any further questions from the learning guide before I sign off for the day. Just a reminder that Monday's class, I'll go over any questions you had on anything from Unit 5, anything at all, and then hopefully you can submit the learning guide on Tuesday and then write the test on Wednesday. We're going to start right on Tuesday's class next week into Unit 6, which is kind of more of the same stuff that we've been dealing with, a lot of kind of modifying equations. We're going to look at graphing still, slopes of lines, intercepts, that sort of thing. So just more of the same in Unit 6. Abby's asking, can we go over the first fill in the blanks on the second part of the learning guide? Page 5. 7, 6, 5. A function performs an operation on an input value and produces. I'm going with output probably, or output value. An x-intercept is where the graph crosses the x-axis. The y value will always be 0. So we looked at a few equations. We substituted y equal to 0, solve for x. Same thing when the sort of the opposite. So if we're talking about the vertical axis, y-axis, the x value will always be 0. And remember, if we have a graph, we have our x values, we have our y values. If I had some point, let's say it's on the y-axis, I haven't gone away from the y-axis to have an x value. So all of my x values here on this particular point are always going to be 0 for x, and then my y value is going to be whatever it is. Same thing goes for the horizontal axis. If we're talking about a point on my horizontal axis, so let's put a point here, I haven't gone above the axis to have a y value or below the axis to have a y value. So my y values here are always going to be 0. Anything on that horizontal line, you'll end up with a 0 for a y value. So to find the x-intercept for an equation, we substitute 0 for the y value, then solve for x. To find the y-intercept for a linear equation, we substitute 0 for the x value, and then solve for y. And I think the next 3 examples, 6, 7, and 9, are all doing exactly that. So hopefully that kind of sets you out on a successful route and helps you guys kind of wrap your brain around that sort of thing. Funny thing is, we're actually going to spend time looking at this method in the next chapter. So Unit 6, we actually use the same thing to plot lines again. So we're going to go ahead and just see more of this coming up, which is kind of interesting that it comes up in 2 spots. So if you haven't kind of got it yet, it's worth learning because we're actually going to do it again. I didn't think anybody else had any questions, so that's kind of it for me for today. Hopefully you guys come out curling tomorrow. I know there's a ton of people last week, which is amazing. You guys look like you had a ton of fun, and I told you curling's fun. So hopefully you guys can show up tomorrow for curling, and I'm going to see you guys on Monday for a review, and then we'll do a test on Tuesday or Wednesday for Chapter 5. So thanks very much, guys. Hopefully we'll see you tomorrow. If not, have a great weekend, and see you on Monday.